You ever stop and wonder how your computer actually handles text? I mean, from a simple search you do online to incredibly complex software, it really all boils down to two fundamental concepts: C strings and pointers. And today, we're going to crack that code. By the end of this, you'll see the really elegant logic behind what can often look like some pretty intimidating stuff.
Okay, so let's start with something we all know, a word search puzzle. For you and me, finding a word in here, say chess, is pretty straightforward, right? Our eyes just scan the grid, we see patterns horizontally, vertically, even diagonally. It's totally intuitive for us. But here's the thing. For a computer, this grid is just a meaningless block of data. It doesn't see letters or words the way we do. So if we want to program a solution for this, we first have to understand how a computer represents and works with text. And in the C programming language, that takes us straight into the world of strings.
So, how do we actually get anything done with text in C? Well, the good news is you don't have to start from scratch. C gives us this awesome, powerful toolkit of pre-built functions that makes handling strings, honestly, so much easier. Let's take a quick look.
All you have to do is include a single file, it's called string.h, and boom, you get access to all these tools. You need to know how long a word is? There's string_len for that. Need to check if two words are exactly the same? That's what string CMP is for. And for our puzzle, if you wanted to find the word CAS in one of those rows, well, you'd use string_str.
These functions are super useful, but how do they work? I mean, how does strlen just know the length of a string if you don't tell it? It kind of feels like magic, right? Well, the secret isn't magic at all. It's all in how C actually represents strings down in the computer's memory. Let's pull back that curtain.
All right, let's get into what's really going on under the hood. To really get good at C, you have to understand what a string is at the most basic level. And once you see it, I promise you, all those functions and all their weird rules are suddenly going to make a whole lot of sense.
So here it is, the big secret. C doesn't actually have a special string data type. A C string is nothing more than an array of characters. That's it. It's just a bunch of individual letters, numbers, and symbols, all sitting right next to each other in a line in memory.
And this brings us to the single most important rule of C strings. Every single string has a secret ingredient at the very end. It's a special character called the null terminator. It looks like a backslash and a zero. Now, this little guy is totally invisible, but it's the critical signal that tells functions like strlen where to stop counting. Without it, the function would just keep on reading through memory forever. And believe me, that's how you get chaos.
Okay, so strings are just arrays of characters. Got it. But think about this. What if you have a really, really long string, like a whole paragraph? When you pass that to a function, does the computer have to make a huge, slow copy of the entire thing every single time? No way. That would be incredibly inefficient. And thankfully, C has a much, much cleverer solution for this: pointers.
Pointers are without a doubt one of the most powerful features in C. They're the real key to understanding how the language handles things like strings and other data efficiently. So let's break down how they work.
A pointer is just a special kind of variable. Instead of holding a value, like the number 42 or the letter A, it holds a memory address. It's the location where some other piece of data lives. It's kind of like having a sticky note that just says, the info you actually want is over there.
So, how do you get one of these addresses? Well, you use the address_off operator, which is just the ampersand symbol. If you have a variable called num, writing and num doesn't give you the value inside num, it gives you the specific memory address, the exact spot where that value is being stored.
And the flip side of that is the dereference operator, the asterisk. If a pointer is holding an address, putting an asterisk in front of it is like saying, hey, go to the address you're pointing to and tell me what value you find there. It follows the address to go fetch the actual data.
So we have strings, which we now know are just arrays of characters, and we have pointers, which hold memory addresses. Okay, now for the real aha moment. What happens when we put these two ideas together? This is where the true power and elegance of C really starts to shine.
And here it is. This is the big reveal. When you use the name of an array in C, you're really just using a pointer. Specifically, it's a pointer to the very first element of that array. This is why functions work with strings so fast. They don't get a copy of the whole string. They just get the starting address. That's it.
Just look at this. It perfectly shows the idea. On the left, we've got the familiar way of looping through an array, using an index like array II. It's easy to read. But the code on the right, that shows you what's really happening under the hood. We create a pointer, we aim it at the start of the array, and then we just increment the pointer to hop from one element to the next. This is much closer to how the computer is actually thinking about it.
Now here's the really clever bit about what we call pointer arithmetic. When you write PTR++, you're not just adding the number 1 to the memory address. The C compiler is smart. It knows the size of the data type the pointer is pointing to. If it's a pointer to a char, sure, it moves forward 1 byte. But if it's a pointer to a 4-byte int, PTR++ automatically advances the address by 4 bytes to get you perfectly to the next integer. It's brilliant.
And look, once you get this, all of those common, tricky C pitfalls suddenly make sense. These aren't just weird rules to memorize, they're the logical result of how this all works. For instance, why can't you use the double equal sign to compare strings? Well, because you're not comparing the letters, you're just comparing their memory addresses. And trying to copy a string with a single equal sign? Nope, you're just copying the address, not the actual text. It all clicks into place.
So there you have it. By understanding that strings are just character arrays that end with a special null character, and that they're handled super efficiently using pointers that hold memory addresses, we've basically replaced confusion with clarity. We've seen the logic behind the magic, and that's always the key to mastering any complex system. So the question is, what are you going to demystify next?